Let's talk about the difference quotient. As I mentioned in the last video, the difference quotient is a huge thing in calculus. It is the beginning of calculating what we call the derivative, which is huge. So in 1050, you don't actually calculate the derivative because that's a calculus thing, but you do start by finding and simplifying this difference quotient so that you're on the way to calculus topics, because that's what 1050 is. It's kind of a pre-calculus class. It's preparing you for that. So here we are. What I want to do is take this difference quotient first and show you that there are three parts to this difference quotient. I have this part, then I have a big subtraction sign. Next I have this part, and it is all over this part. So those are the three pieces of the difference quotient. So anytime we need to find this, we're going to find it in pieces. So we're going to find f of x plus h first. Then we're going to find f of x. And then we're going to put it all over h and simplify it. So let's find f of x plus h first. This is just a plugging in. So this is our big fat parentheses. Boom! Ta-da! I took what was inside and I plugged it inside my big fat parentheses. F of x is just the original equation. I don't really need to worry about that. So now what I'm going to do is put my pieces all together into one equation. So my first piece is my f of x plus h, which is that. Then I have a big subtraction sign, and then I have my f of x piece. Now remember, like we talked about in the last video, get in the habit of anytime you subtract, you want to put parentheses around it so that you will instinctively remember to distribute that negative. So we're going to add those parentheses, and then we have all over our h. So those are three pieces. Now we're going to start to simplify this. So first thing, I'm going to take this squared and multiply that out. Squaring is timesing by itself like that. I'm going to distribute this negative, negative x minus h. Then I have this minus 2. Then I'm going to distribute this negative, minus x squared plus x plus 2, all over h. And look at that. We kind of have some stuff canceled, so that's nice. The negative x and the positive x will go away. The negative 2 and the positive 2 will go away. So next thing, I need to FOIL this out, simplify it all. So x times x is x squared, x times h is xh, h times x is another xh, so that is 2 xh's, and then h times h is h squared. And then I look at what I have left here. I have a minus h here. I have a minus x squared there, and it looks like that's all I've got, and it's still all over h. And hey look, even more stuff cancels. X squared minus x squared, gone. So now it looks like I'm left with 2xh plus h squared minus h all over h. Now the next thing I want you to notice is that everything up here in the numerator has an h in common, which is fantastic. That means I can take that h out. So I'm going to take this numerator right here and take an h out of everything. Remember, taking out means basically dividing all of these things by h. So 2xh divided by h is just 2x left. H squared divided by h is 1h left. And then h divided by h is 1. And all over the h. The whole reason we did that is because now I have an h on top and an h on bottom that will cancel. So here is my final answer. all simplified out. And that, my friends, is actually only one step away from what in calculus we call the derivative. So, remember, in this class, we're just simplifying these things. We're not actually calculating the derivative. You don't have to do the last part. We're just plugging it in and simplifying. So let's try that on B. I'm going to start with my pieces. I have we're with G now. G of x plus h. Do my big fat parentheses with x plus h replaced in the middle. Then I have my g of x, which is just the equation itself. And then I'm going to plug it all in and put it over h. So I've got g of x plus h. And then we have a big minus. And then we have g of x. You could put parentheses around that if you want because it's a minus. But because it's already a single thing, there's not really any distributing that has to happen. You don't really need to worry about the parentheses this time. And then all over my h. There's my three pieces. Now, I need to simplify this because I have fractions and fractions. So, that means I need a common denominator here. One of the easiest ways to get a common denominator is to multiply by the denominator of the other side, of the other fraction. So this is the denominator of the other fraction. I'm timesing it top and bottom by it, so it stays balanced. And then I'm going to do this one, multiply by the denominator of the other fraction. And now you'll notice that their denominators are the same. They are common. So what I'm going to do next is distribute this 3 into here, which gives me 3 times 2x, 6x. 3 times 1 is 3. And now I have this big fat subtraction sign. And I'm going to distribute all of this together. But this is kind of a lot happening, so I'm going to distribute this one first. So that's 2x plus 2h, and then my plus 1. Now I'm going to distribute the 3 in. So 3x, 3 times 2x is 6x plus 6h plus 3. And now I want my parentheses because now I can distribute that negative. And it's all over our common denominator, which is 2x plus 1 times 2x plus 2h plus 1. Just distributing that. And this is still all over h. So we still have fractions and fractions here. That has not gone away yet, which means we still have work to do. So let's distribute this negative and see what happens. So I got my 6x plus 3. Let's distribute this. So minus 6x minus 6h minus 3 all over my common denominator that I came up with. All over h. Hey, things are starting to cancel. 6x minus 6x, 3 minus 3. Beautiful. So now I've got this negative 6h all over this wicked common denominator. I'm running out of room. All over h. So now that I have simplified this as much as I can, now I can finally do keep, switch, flip. So remember that means keep the numerator the same. There's my numerator. Switch to multiplying and then flip the denominator. And look at that. I have an h on top and an h on bottom that will cancel, just like last time. So now I'm left with a negative 6 over this common denominator. And that is actually as simplified as we want it. You could FOIL out that denominator. I actually wouldn't because you don't really need to. In calculus, we would prefer to leave it like this for what the next step is. So there we go. There is your difference quotient. In the next video, we're going to talk about what function composition is. See you then.